Okay, so again, good morning, students. We are starting with the soil as a three-phase system. If you can see this diagram, this is the original diagram. If you take a handful of soil, then you will have some soil solids, then you will have some air, and then you will have some water. So this is your air and this white color is water. So liquid phase and gas phase. So there will be some air, there will be water and there will be soil solids. Then how the formation of soil is done. So first you have done geology. So what is given? Disintegration of rock, then decomposition of organic matters. So what does it mean? You have already studied. Disintegration of rock means the parent rock is having certain weathering actions, and with that chemical weathering actions, the parent rock is disintegrated or broken into small types of stones. Then decomposition of organic matters. Organic matters, vegetative matters, are there. They are growing in trees. When they grow in trees, the trees roots push the rock by disintegrating in them into small soil particles. Then what is rocks? So rocks are of three types. One is your igneous rock, second is your sedimentary rock, and third is your metamorphic rock. Then what happens? The rock weathering is happening. When rock weathering is happening, what you get? You get mineral grains. From that mineral grains, what is happening? You get a three-phase system. You get air, you get water, you get soil solids. In soil solids, you may also have the decayed organic matter. So this is how the soil is formed. Now, soil forming rocks. So what is soil forming rocks here? So there are certain points. So let us go one by one. So first is your rock, outer rocky shell or crust of the earth. That means it is the uppermost part of the parent rock, a big parent rock, which is known as your outer rock shell or crust of the earth. Earth means soil. Rock is also soil for us. Second is your igneous rock, which is obtained from cooled from molten state when lava goes inside the sea. Then the big rocks are formed, and those are known as igneous rocks, which is known as cool from molten state. That means lava is cooled, and when they are cooled, they become a stone. So for example, they are granite, they are diorite, they are ballast, etc. Then sedimentary rock, deposit from a fluid medium. Sedimentary rocks are again very sandstone, limestone and shell. They are very brittle. If you break it by hand also, they will break. Metamorphic rocks, they are from igneous and sedimentary rocks. Okay, they are pre-existing rocks by the action of heat and pressure. So quartzite, schist and slate are the examples of this. So what is the geological cycle? In geology, you have already studied what is geological cycle. So first is your parent rock. When millions of years happen, parent rock disintegrates, and when parent rock disintegrates, it becomes soil. Again, the deposits of soil is there, and again the parent rock is made. So this is the cycle. Rock, millions of years it will become soil. Again, millions of years it will become rock. So this is geological cycle. So there are certain points. What are those? Modify the earth's surface, destroy old rocks, create new rocks, add complexity to the ground surface, and which forms the soil. It modifies the earth's surface, destroys old rock. I mean, this is the rock. It destroys the old rock by weathering effect. Then they create new rocks. When soil is formed, again new rock is there and add complexity to the ground surface and then forms the soil by weathering actions. Next is introduction to geotechnical engineering. Kindly see the diagram. All civil engineer begins with the geotechnical engineering. If you see that this is some certain type of a structure which is resting on the ground. So this is the soil which is used for foundation material. Here the ground means this soil is used as foundation material. Then what happens? Typical geotechnical project. Okay. So first what happens? What is happening? First, the soil, you dig the soil samples are taken to the geotechnical laboratory for testing. Then some properties are obtained from this geotechnical laboratory, soil properties. They are given to the design office for design analysis. Design and analysis is done when details of design are coming to the construction site, then the construction of the structure begins. So this is the construction process. First, soil to the geotechnical lab, obtaining the properties, designing it, and design is transferred to the construction site, and then the construction is done. Then what are shallow foundations? So shallow foundations and deep foundations, there are two types. Kindly have a look in the diagram. Shallow foundations for transferring building loads to the अंडरलाइनिंग ग्राउंड. ठीक है, ये फॉर्म ग्राउंड है, ये आपकी बिल्डिंग है और दिस ग्रीन टाइप ऑफ thing is the foundation, mostly for firm rocks or light loads. If there is a rocky soil, if there is a firm soil, you are getting concrete materials, rocks are available, hard strata is available, then you give the shallow foundation of this type for any small constructions or big construction. So this is some example of shallow foundation. These are footings and these are coming out of this. These are now design of shallow foundation system and bearing capacity failure. Transcona grain elevator. This was the construction done on the soft soil in from Budu to this was the construction done, and because the bearing capacity was not so taken in down, okay, only because the bearing capacity failed. Now foundation system. Kindly have a look on this diagram, on this picture. So this is the Leaning Tower of Pisa. So designing of shallow foundation system, this is differential settlement. There are two types of settlement. One is your equal settlement and another is your differential settlement. Here you can see that the original position, if you can see the line of original position, if we draw the straight line, ठीक है, अब ये इतनी तो straight नहीं बन रही है मेरे हाथ से, but if you draw the straight line of the foundation, you can see that there is an tilted angle, यानी कि इतना ज्यादा tilt हो गया है आपका leaning pisa. So ये जो angle है, ठीक है, ये जो angle बन गया है, so this is because of differential settlement. That means here the soil is so soil has failed. ये यहाँ की soil जो है वो थोड़ा सा ज्यादा दब गई है, कंप्रेस हो गई है, जिसकी वजह से ये टिल्ट हो गया है. ओके. Now deep foundations. For transferring building loads to underlying ground, most for weak soils or heavy soils, we are giving this piles. Piles are of two types, frictional piles and end bearing piles. If you are having a bedrock here, अगर आपको यहाँ पे bedrock है तो आप यहाँ तक के पाइल को ला सकते हैं, लेकिन अगर आपको पूरी वीक सॉइल मिल रही है तो एक पर्टिकुलर लेंथ तक आप वो पाइल को लेकर आ सकते हैं. ठीक है. When there are heavy loads you have to and weak soil, then you have to consider pile foundation. So foundation system, these are the driven piles. Piles are driven by this type of tamping rods. So this is an auger. First you drill the soil, then you insert the cage of the pipe, and then you do the concreting in this pipe, drill shafts. So what are the retaining walls? The retaining walls are the soil for spreading laterally. So these are the retaining walls. If this is a tunnel and it is a road or a train, then these are the retaining walls. And upper side also there is a road. Then these are the retaining walls. We should not slide inside. So these two are the retaining walls, and this is the slab which is constructed over the soil. So earth pressure and retaining walls. So there is the soil over here. So this is a retaining wall which is provided for this road. This is a retaining wall. Here also there is a there is a soil here, there is a slope here, and there is a again one construction flyover over here. So this is a retaining wall provided to stop the soil slide here. Again, these are the gabions. These are made up of stones, small stones. No concrete is used for this. This is the soil material, so this should not slide down here in the road. So these gabions are given here. Again, here is the road. Again, this gabion is given here, and the train is going from upper side. So this is soil nailing, this is the retaining wall, and by inserting the steel rods inside this construction, which is known as your soil nailing, here beside this retaining wall there is a soil. So this soil should not push this retaining wall. That's why the soil nailing is done inside. So this nails will from this retaining wall will go inside the soil. So these are the sheet piles. If there is a ship over here, there is a construction over here, and ships are moving. This is water level. So what will happen? You have to give some sheet pile here, which is anchored at some level, because sheet pile is a slender member and it should not buckle. Okay, what happens? The soil is a slender member, so it should not buckle like this. ये buckling should not be there. Okay, so when buckling will happen, the sheet pile will fail. So this anchor is given here so that it will remain straight. So this is how the sheet pile is taken care. These are again the sheet piles. Whenever you are constructing any structure here, these sheet piles are constructed in this river bed for stopping the water coming inside here, and then the construction is done. These are the sheet piles again here. These are sheet pile walls in a zigzag manner. If you can see, then water will not get inside the construction material. This is how the construction is done. These are the tunneling. Now earthen dams, if water level is here, for impounding water, this is the clay core and this is the shell and this is the soil. Then weight and unit weights. Force due to mass, weight, more important than mass. So what will be the weight? Anyone? So weight will be equals to mg. Then unit weight is there. Then unit weight gamma. Bulk unit weight is given by W upon V. Weight upon volume, which is mass into G upon V. Therefore, gamma is given by rho into G, where M by V is your rho, density of soil. Then, when you are having some small element and there is a vertical stress here, so how the vertical stress is given for the Z height, we don't know how much height is there, where is the hard strata. So the stress in vertical direction is given by rho gz and sigma v equals to gamma into z, where gamma is the, what is gamma? Unit weight of soil. Then specific gravity. So specific gravity G, it is given by density of material upon density of water, rho upon rho W. So G also in unit weight of material upon unit weight of water, which is given by gamma upon gamma W. Gs is approximately equals to 2.65 for most of the soils. Gs is useful because it enables the volume of soil particles to be calculated from mass or unit or weight. So what will be Vs? Volume of, this is Gs required, Ms upon rho s, mass of soil solids upon density of soil solids, which is given by mass of soil solids upon rho is again Gs into rho s, which is given by M upon G, and M upon rho gives W upon gamma, where Ws upon Gs up into gamma W, where gamma W is the unit weight of soil. Then voids ratio. The voids ratio is defined as Vv upon Vs, where Vv is the volume of voids and Vs is volume of soil solids, and porosity is given by Vv upon V, where Vv is volume of voids and upon total volume. Then relation between this is given as Vs is equals to total volume minus volume of voids equals to 1 minus porosity into volume. So if you solve all this, then you will get E will be equals to N upon 1 minus N. Then degree of saturation, it is the ratio of volume of water upon volume of void. So if you do all the examination, so if you do all this, we have already done this expression in GT1, then you solve all this total derivation, then you get SR equals to WG upon E. Remember that if on the voids may be filled with air or water or both. If air is present, then soil is dry, and when degree of, and the degree of saturation is 0, SR is 0. On the other hand, the voids are filled with water and the degree of saturation is 100. So sometimes it is dry and sometimes it is 100% saturated. Air content, again it is given to you. I think this is the we'll do in next class, because it is quarter to 11 and your next class will start with 11 o'clock. So thank you students for attending the class. Whenever I will take the next class, I will inform you again. Thank you so much. If you have not followed anything, if you have any queries, you can just call me. My number is with you. Thank you so much. Any questions you can pen down. You can write down in the chat box, or you can just pen down in the WhatsApp number.